Okay, in the previous video we introduced you to the concept of a power function, any function that is defined that is being raised to some sort of power, and we taught you how to add and subtract and multiply and divide. Well, whenever you have defined functions or two separate defined functions, there's also a fifth operation that can take place, and we call this composition. So basically what composition of functions is basically whenever we're going to embed one function in another. And in simple terms, this is basically substitution. So if we substitute one whole expression that represents a function in for the other x value, we can end up creating a whole new function through composition. Now, it's very important that you pay attention to the order of the functions given, because depending on which one comes first, that's the one that's receiving or accepting the other function. That's the one you're going to be embedding into. And so that is going to be more or less the parent function or the main function. So you can see here, and we'll prove this through our examples, that when we embed one function in the other, and so in this case, first case, we embedded g of x inside of f of x, and so you can see the way that's written. And when you pronounce that, that's called f of g of x. And on the reverse side of that, you can see in the second one we embedded f of x into g of x, and so g of x in the second one is the main function that is receiving the composition. So the second one is called g of f of x. Now, those two are not necessarily equal, and so we'll see how that plays out through a couple of examples. Now, again, you are going to be using exponent properties in these problems, and depending on what type of functions you're given, you could either be adding and subtracting or multiplying and dividing. So combining like terms and exponent properties will come into play. Now let's take a look at example number 3. Now I've color-coded some of these for you to get a good feel for the substitution process. So if we look here, we've defined two functions. We've defined f of x and we've defined g of x, and you notice they're completely different. Now I want you to be clear, this right here, that is an exponent. Okay, so 3x raised to the -1 power, whereas in the second one, g of x, we're doing 2x minus 1. So I don't want you to get those confused. I know they look kind of similar there. So if we look at part A basically asks us to embed g of x into f of x. So let's take a look at this, what we're basically going to do. We have an f of x value, and what we're saying is, in place of that x value, we want you to replace that x value with the whole g of x function. So what ends up happening is we get a composition of the f and the g of x functions together. So we're going to actually replace x in all of the f of x values. The f of x functions, we're going to replace all of the x values with the g of x expression. So you can see here in part A, we're going to replace all of the x values, and so in this case we only have one x value, 3x raised to the -1 power. And in the second step, we've actually replaced the x value with the full g of x expression. So that full function for g of x is now replacing the x value, and so now we have a new function, and of course you can see here that there's some simplification that needs to take place, and you would create that. And so you see the new function f of g of x is represented by 3 over 2x minus 1. Now, let's turn that around. You can see in part B, we go the opposite direction. we see g of f of x, so we're embedding f of x into the g of x function this time. And so you can see in part B I've highlighted that or colored that in blue. And so whenever we embed the f of x function in place of x, we again have to simplify the given problem. And so in this case, when you finish simplifying, we ended up with 6 over x minus 1. And so you can see very clearly from those two answers that f of g of x does not equal g of f of x. Now, there are some special cases that they may equal to each other, and there are some special cases involving composite functions that we'll discuss in the next unit when we discuss inverse functions. So it's very important that we learn this skill, composition of functions, because we'll be using it in future lessons. Okay, so let's just go ahead and finish this unit up by working a couple sample problems. So you can see sample problem 3. We define a couple functions for you here. F of x and g of x are both defined, and so in part A, we want to do f of g of x, so that's one direction. In part B, we want to do g of f of x, which is the opposite direction. And then down here a little further we have a C, where we're going to embed the same function inside of itself. So we're doing f of x, and so we're going to work on those three problems. So what I want you to do at this point is pause the video and work all three composite functions, and then come back and see how you did. Okay, if we look at part A, we're going to start off with the f of x function. And so the f of x function in part A looks like this. F of x equals 2x to the negative 1 power. Now, what I'm going to do here is I'm actually going to embed the g of x function in place of all of the x values. So you can see we have an x value here. That's the x value of the function. Now we want to replace it with the g of x value, and the expression for g of x, the function is x squared minus 1. So you can see we've now replaced the x value with the g of x function, so we have f of g of x. Now, what we've got going on here is we have the part in parentheses being raised to a negative exponent. And if you recall from our exponent properties, that's understood to be over 1. So this whole part that's being raised to the negative 1 property exponent needs to be brought down so that we could have it to the positive exponent. So our final answer here is going to be f g of x equals 2 over x squared minus 1, and remember that's being raised to a positive first value, which is understood. And so we now have our new composite function. Okay? Now, let's reverse that process. So if we reverse that process, or do the opposite side of it, we're going to have g, and I'll go in a different color here. We're going to have g of x, which is simply x squared minus 1. And in place of the x value, we are going to embed f of x. So in place of x, we're going to embed the f of x. Now here's the thing. This is where a lot of students get confused. We really need to rewrite the entire g of x function, but leave some space where the x value is for us to replace it with the f of x value. And if we look back up here, our f of x value is 2x to the negative 1. So we have 2x to the negative 1. That represents f of x. So a lot of times students get confused because they don't know how to write out the g of x function and where to put the f of x. But if you would simply just repeat writing the g of x function, and then in place, obviously, of the x values, you're just going to substitute the f of x function in there. Now, if I'm to work this, I have to do some exponent properties here. So the very first thing I need to do is I need to distribute the 2 to both parts inside there. So that's going to equal 2 squared, which is 4, and then 2 times negative 1 is going to give me x to the negative 2 power, and then minus 1. And then again, we remember that this negative value goes with the x only, and it needs to be brought down to the bottom or to the denominator to change it to a positive. So what we have there is, and I'll write the whole thing, g of f of x equals 4 over x squared minus 1. And so that is our final composite function. And then lastly, we're going to do something that's a little different. Now we're embedding f of x inside of itself, and so we start with f of x, which equals to 2x minus 1. And of course, we're going to replace the x value here in our function. And notice I've left some space where the x value was. And so now I'm going to replace it with itself, with the f of x function. So I now have to put the entire f of x function inside of itself. So now that we've created the composite function, we just need to do some basic exponent properties. And again, we're going to distribute that negative exponent to everything inside of the parentheses, which is going to give me 2 to the negative 1 power. And in this case, a negative 1 times a negative 1 is a positive 1. And then, of course, we now can actually open up those parentheses. So that's like saying 2 times 2 to the negative 1 power times x. And of course, we now have to take the negative value exponent and bring it down. And so when I do that, I end up getting 2 over 2 to the first power times x. And of course, 2 divided by 2 is 1, so we are simply left with x. And of course, I should write my final answer showing my composite function. So f of x equals 2x. Now, when we get into the next unit talking about inverse functions, we'll talk about composite functions again and how they can help us determine whether a function has an inverse or not. So that is the end of the unit on power functions and composite functions.